Today I will be introducing our first real-time spectrum analyzer, the RSA5000. This real-time spectrum analyzer is designed to provide important analysis capabilities in each stage of the RF design process while being flexible enough to adapt to how each engineer works. For instance, the instrument can be used in real-time mode or more traditional swept mode. The unique combination of performance specifications, advanced measurements, real-time spectrum visualization, and Rigol value makes the RSA5000 a powerful instrument for any RF engineer. On the front panel of the RSA5000, we've got our power button, 3 USB ports. One's for your USB stick or flash drive, your wired keyboard and mouse if you so desire, and audio out for headphones or speaker. And we have our tracking generator, which is available on all TG models. And so it's up to you. And then we've got our input, which currently we've got a 2.4 gigahertz antenna, just so we can see the Wi-Fi going on in the room currently. And then the instrument itself has a 10.1 inch touchscreen display, which can allow us to easily change values on the fly via the touchscreen, or we can use our more traditional soft touch keys themselves. In this mode, the instrument can sweep the entire frequency range for this model at 1 milliseconds. And this instrument comes with 1 Hz RBW and a noise floor of negative 165 dBm. And in sweep mode, we can do our more traditional RF characterization testing, including VisWare testing, harmonic distortion, channel power, and total power. We can also set the instrument into real-time spectrum analysis mode for real-time sampling, which gives us the ability to see much more complex and intermittent signals due to the real-time bandwidth and very low POI. With up to 40 megahertz of real-time bandwidth and the ability to capture a pulse as short as 7.5 microseconds, we're able to capture most intermittent signals and complex signals. Here we can actually see on the screen the Wi-Fi channel nearby, just capturing by the antenna. And we can see with our full 40 megahertz bandwidth, we're able to capture the entire channel, and in real-time mode, instead of seeing the bouncing peak as before in swept mode, we're actually able to see a much more defined channel. Then we can actually switch it out of normal mode and put it into a much more complex and interesting mode like density, which will allow us to see, just more or less give a visual representation of how often each RF signal is coming in. We can also put the instrument into real density and spectrogram mode, so we can also see it via time below, along with seeing our density above. In real-time mode, we're able to use much more complex triggers, like our frequency match trigger. Then we've also got our power trigger, and then our 2 external triggers and free run. With these sort of trigger options, and with the different abilities to view the signal and it being a real-time spectrum analyzer, we're able to view much more complex and intermittent signals. On the back of the instrument, we'll find the serial number along with the power port and fuse cover. Then we can find the cover for where you can actually add an optional higher accuracy clock at any time. And right here we have our IF SMA connector, the HDMI port. Then we've got another USB host along with our USB connector, so you can control the instrument with your computer. Our LAN port, then 2 triggers, trigger ins, and this one can also be a trigger out. Our 10 megahertz out, in case you wanted the reference, and then a 10 megahertz in for a laboratory 10 megahertz reference. The RSA5000 combines real-time capture and sweep capture capabilities with a flexible form factor, allowing an engineer to select their preferred testing techniques, interface, and use modes. With the frequency ranges of 3.2 gigahertz and 6.5 gigahertz, the RSA5000 is ideal for analysis of components and complex signals in EMI, IoT, Wi-Fi, cellular, and a variety of other wireless communication applications. The RSA5000 gives engineers increased control, accuracy, and flexibility over their RF measurements throughout the design process, providing uncompromised performance at an unprecedented value. If you have any questions regarding this instrument or family of instruments, please contact us at Rigol or visit rigolna.com for more details.